Can you see my screen?
Yes, I see your screen. Yes, sir.
Okay, all right. All right, the first thing we want to do here is set up our machine tool. And I've already set it up here. I'm using the manual definition. The machine that you're getting or you're going to be using is this 4-axis machine, and it's going to be a head configuration. And then we can set up, let's ignore this for a minute. The most important thing that we want to set up here is to define which way the rotary axis is rotating. And so we're saying the rotary center is at the XYZ 0, which is right here at this green, where you see that green arrow. Right. And then the green arrow, the thick green arrow there actually tells you the rotation axis, which I have selected as the negative y-axis. If you're familiar with Rhino at all, the red represents the x-axis, the green is the y-axis, and the blue is the z-axis. And so here what I've defined is I'm saying my machine tool rotates about the negative y. That's the way Paul had defined, I guess, has defined this machine. So that we need to set that up first. It's a pretty simple way to set it up. Really, the other parameters don't matter much. But they're important if you're getting into very tight corners and things like that. But for our purposes, for our demo, we won't mess with them. The most important thing is defining the rotation axis. Yeah, stop me anytime, Philip, if you have any questions.
Yes, sir. I'm following you so far.
Okay, all right. So now let me, the next thing we want to do obviously is select our post processor, or what we're going to be posting to. And the system we've already set up, I worked with Paul to set up this CNT Seawall post processor. And then when you buy the product, you will get this post with it. And so if you select it, we have hundreds of posts that you can select from. So in case down the road you buy another machine, there's a whole bunch of machines you can select from. So right now, let's use the CNT Motion Seawall. And then there's some post-processing options that you can set up, the file name that you want to output to, what is the program that you want to use when when the posted file is actually created, things of that sort down here. So for now, I've got that post processor set up. I got the machine tool set up, followed by the post processor. The next is creating what's called a stock model. This is basically your raw stock or workpiece that you're working with. Here you can do a simple bounding box stock if you want, which is basically does a box around all your part geometry. Right. So let's go with that for now. And then I can show you some advanced features. We have something called stock from selection, which is you can just select this part as your stock model, and then or create another stock model without these holes and things of that sort. So you can actually see how these slots and holes are machined. But for our purposes, I'm going to just do a bounding box as if you're cutting it out of a block of metal like that. So what's your raw stock look like? Is it a rolled material, or how are you getting your raw stock?
What you have on the page right there is very close. Usually the wall thickness is only about an 1/8 inch around all the way most of the time. And it may or may not have that screw spline like yours shows. That just depends on the manufacturer and the type of wall. But and typically it has what we call a tongue running right down the middle of the top section. That's usually 1.5 inches tall, maybe I don't know, 1 inch wide by 1.5 inches tall.
Like a rib kind of thing.
Yeah, so because it gets an exterior piece of metal screwed to the main piece of metal, and that's where the screws spline into in the tongue to attach the exterior ornamental piece of metal to the structural metal.
Okay, all right. So let's go with this one. I mean, obviously you're designing it in some other system. Do you have a CAD system right now, or?
Yeah, we have AutoCAD too.
Okay.
And I was playing around today trying to figure out how to draw the solid object like that, like you're showing in Rhino CAM, but I have like the outline of our metal in there, and
Okay.
I just was trying to figure out how to make it solid so I could do the machining processes like you're showing now.
Yeah, all you would have to do is do an extrude. If you have the cross sections, just select the cross section, and you can do an extrude solid, extrude planar curve, and then you can do a straight section. So very quickly, I can show you that. So let's say I can create a rectangle. Do a rectangle here. Let me do object snap. I'll start the end. I'm selecting the object snap. You know, this rectangle is easier to draw. Just go snap to those endpoints. By the way, Rhino is very similar to AutoCAD. That's where they come from. In fact, the Rhino, they started out as AutoCAD resellers, and then they figured out that AutoCAD does not have surfacing, so that's how they started the Rhino product itself. So, okay, if you have the outline like that, just go to solid here, and then extrude planar curve straight, and then you can just do that. That's how you do the solid. Very simple.
That's exactly what I was looking for.
Okay. All right, so let's go with programming now. Now that if you have the model created, and then let's say you want to machine this pocket or a hole, and then come to this side and machine that, and then you have a slot on this side. Let's see how we can program those. So this one is a normal configuration. When I say normal, the tool axis is pointing up in this direction. So the tool is actually coming down this way. So this is our standard setup. So let me start with this. I'll go to this, create a regular setup. And you can see the setup coordinate system is being displayed on top of the world coordinate system. Actually, let me turn off the world coordinate system display. And then I'll go to the setup. And you can see this is my tool. The blue arrow is my tool axis. So it's pretty standard setup. So I'm just going to select generate. So that creates a setup. Actually, let me move that copy and move it up to the top because I'm going to start off as that. Oops. Okay, there's my setup. I'm going to call it. Let me rename that to standard setup for lack of a better name. Okay, now once I got that, now let's go ahead and try to machine this up here, which will be nothing but we can do a simple pocket operation, or if you just want to go around and then make that piece in the middle fall down, which is probably what you would do. I would use a profiling operation. And these are our 2.5 axis, I'm sorry, the machining, different types of machinings, operations that you can create. So we'll start with 2.5 axis. I'm going to start with the profiling. I'll take profiling and then select curve and edge region. So I'm just going to select those edges. So that's going to be my drive region. And then I'm going to select my tool. I've already defined a bunch of tools. I loaded these tools. I'm going to create a half inch, select a half inch cutter. The different types of tools we can create are, we can go with ball end mill for finishing, flat end mill, corner radius end mills, taper, V-mill, taper with corner radius, shell mills, dovetail, fillets, lollipop. And you can also define your own user-defined. If you have some sort of form shapes that you want to machine, you can create your own user-defined shapes as well for your tooling.
Right.
So it's quite powerful in that sense. Okay, so I'm going to set, that's my tool that I'm going to use. Oops. Okay, and then next we can set up feeds and speeds. I'm just going to use my default feeds. There's quite a bit of control here that you can play with. I don't want to complicate things too much at this point. Then we can set up the clearance plane. It's automatically setting up the clearance plane a certain height above the part geometry. We can leave it at that. Let's go to cut parameters now. Okay, so we're just saying, okay, what's the tolerance I want to use for machining? I'm going to use a finish tolerance of 1000s here, and then 0 stock, which is the thickness that I want to leave. And I can go mixed cut direction or either climb or conventional. I'm just going to do a single pass, so it doesn't matter. Let me pick up climb then. And then where do I want the cut to start? The largest, the longest point. I'll take the longest curve section of my cut geometry, and that's the midpoint of that is where I want my cut to enter. So, and then cutting side, I can specify, I can, in case I had open curves, I can specify right or left. In this case, I have a closed region. So I'm going to say outside, inside. So I'm going to go cut inside. Let's just generate and see what I get. So there's one pass. So default parameters are set up to be one pass here. So let's say if we want to go multiple passes, so I can open up the operation that I just created. Double click on these parameters icon, and then go to my cut levels tab here and define my cut level. So here I can tell the system where my cut geometry is located. In our case, the geometry that we selected, which is those curves, are located at the top of the geometry. So we're going to leave that at the top. And then we want to specify the total depth of cut. And I can use my little measurement device here and say that's 0.376 or 375. Okay. And then I can machine this in multiple cut levels. So I can say, give me a rough depth of cut as 0.15. Say generate. So that gives me 3 passes. And then I'm coming in at this point, engaging into the material, machining, going down the machine, and cutting that. And I can simulate that. Once I created that, I can simulate it. So it's going to use that. So you are using our stock model, and it's simulating. And let's say you don't want to plunge in here because obviously you got a flat end mill and you don't want to plunge in there. You can go back in there and change your entry exit parameters. We can say a long path, and then leave that there. So now what is going to happen is it's going to come along this path, along that wall, and then ramp down and machine that. That gives you a little bit. So let me simulate that. So it comes in and ramps, as you can see there. And then entry, exit. If you don't want it, you can specify just pull out straight, or if you think you want to pull out of the material, you can do that too, like I just did. Okay, that's a simple profile pass. Any questions, Philip?
No, sir, that was fairly simple enough.
Okay, great. Okay, so next we want to machine this hole here, and let me. So for that we need to flip the part. Or in our case, it's got a table, so we're going to flip the tool. So what we're going to do is, looks like we got Trey joining us now.
Yes, guys. Sorry I'm late. But I hope y'all keep going and don't even act like I'm here. I'm listening more than anything.
Okay, yeah, we're recording it, so you can watch it later. So
perfect.
All right. Okay, so next, what I'm going to do is we're going to machine this face here. So Don, jump in if you have any suggestions on anything I need to show. So.
No, everything looks good so far.
Okay. All right. So next, I'm going to machine this this hole. So for that, what I'm going to do is I'm going to rotate my tool. So since we know that our machine tool is set up to be rotating about the negative Y, and I'm going to use my right-hand rule and say to access this face, I need to actually rotate my tool by -90. So I'm going to go to rotate table setup, and you can see this coordinate system is being displayed. Its default is set up to be rotate 90 degrees positive, but I'm going to say, so my tool axis is actually pointing that direction, but that's not what I want. So I want to go the other direction. So yeah, that's what I want. I can set up this setup now. So now this face becomes accessible to me for machining. So this face. Okay, so next let's go and set up the machining for this. Very similar. In fact, I'm going to do the same profiling. We can do a profiling and pick that arc. So for that, all I can do is copy this one, copy this operation, move it down to this setup, and do a paste. Okay, but as you can see, there's a red star next to the operation. It basically says, okay, the toolpath that you've created is not correct, because we got the setups changed because we just copied and pasted. So I know that, so I can go back in there. I want to redo my control geometry. So I don't want I'm not machining that, I'm machining the arcs here. So I can say remove all, and then select curve edge regions, and just go select that, these two. I guess it's not a full arc. And let's hit generate and see what I get. So there, I got the same toolpath with the same parameters, but on different geometry on a different face.
Right.
I'm going to rename that setup to -90. Okay, and then I can simulate that. Now the cutter, as you can see, is coming on this side. I'm simulating it. Okay. And then finally, we want to get back to this side. And very similar, I can either, I'll just do another rotate table, but right now, then I want to go 90 plus 90, which is by default set up correctly. And I hit OK. Okay, and then I can do the same thing. I can do a profiling. I'm not sure how thick that is, so I can do an analysis. I can do, distance analysis. I can say go from here to there. It says ½ inch. So I have a ½ inch cutter, so I can actually do a slotting operation. Drive it right down the middle, and that's what I'm going to do, rather than doing a profiling operation with a smaller cutter, because I'm just going to leave that corners there anyway. So I'm going to rename this. Plus 90. And then we have this under 2.5 axis machining, we have a slotting operation. So we select curve edges, this particular case. Now, that's my slot. The tool, the same for ½ inch. I'm going to select that. Slot parameters. I'm going to say, and then determine close ends, whether it automatically determines whether the slot is open or closed based on the 3D model. Let's just generate that and see what I get. There's one cut. Comes in, ramps in this direction, cuts it, and then gets up. Again, very similar. I can go in and change the cut levels if I wanted more. Sorry, total cut depth. I'm going to select this. It's the same thickness as the other. And I'm going to generate. So I'm going to have multiple slots. Let me delete all of these that I had previously created. Okay, now I can simulate that. There you go. So there's your part programmed from 3 different directions. And then once you're done, the last thing we want to do is obviously, we can do a simulate all if you want from up there, select the machining job and do simulate all. So it goes through and cycles through all of the operations that you might have and creates the simulated model. And then if you're happy with that, and the last thing we want to do is to post it. So we can select machining job again and post all.
Now, what does that do exactly? I'm sure you're about to get into that.
Yeah, hang on one second. It's since I shared the application, it's not sharing this. Okay, I can actually send you the posted file. That's probably better. So what I can't show it to you, but what I can do is I can create. You can see the posted geometry, posted coordinates. So these are all the different go-to motions and things of that sort. In a rotation, everything is already figured out for you when you do the posting. So yeah, so you had a question there, Philip. What does that do? You asked me. So basically that's once you get that file, that's what you send to the machine tool, right?
I see that now after you show me the list.
Okay.
That little pop-up list of it. I saw that.
Yeah, and you take that to the CNT controller and then load that and run it. So